office hours, the link.
All right, we're recording, so whenever you want to start.
All right. So I did throw a link in the office hour notes. So let's see, I'll throw one in this other one too. All right. All right, let's get going. We'll see how long this takes. Let me share. And hopefully this is showing up.
Yeah, I see it.
All right. It does say the infinite window thing. Hopefully I don't run into that. Okay. So I wanted to talk a little bit about the CI/CD stuff. That was sort of my original discussion point, and specifically about the automation jobs and how to create them. But I want to start a little bit higher than that, I think, partially because that might be too in-depth for some people. So I just sort of wanted to start a little bit higher than that, and basically talk about the automation from a high level, and stuff that most people would see if they're a contributor. So if I just look at a normal window, this particular window is the window of pull requests that I am on, that need to be reviewed by me or one of the groups I'm in. So this is just a simple view, but I wanted to sort of talk about a couple of things in the view. So this view has a number of PRs in it. If you look at the PRs, you can see there's some labels that get automatically added, some that aren't. The size labels are automatically added and updated by a bot, so depending on how big of it is. You'll see some get this OK to test, and that basically means that this PR originally had a needs OK label, and that basically means that somebody who is not a member created the PR. So they create the PR. It shows up. None of the automation tests are run against it, and part of this is to prevent people from basically creating PRs that run tests that might be have some nefariousness in the PR. So somebody who is a member must look at the PR and put the appropriate task or comment in it to make it OK to test, which kicks off the test. Some of them you'll see have auto merge, where my mouse went, and we'll talk a little bit about that one later. Some people will set things themselves, which are like the do not merge hold, things like that. One other thing to note on these PRs is there's typically a little symbol after the title. It might be this, what I want to say, I guess, yellow light. Looks more dark yellow, but and basically if you click on it, you can see that 4 of 5 checks are OK. Typically, you will see most of them will say X of X plus 1 are OK. If you see that there's of the yellow light ones, when there's fewer, so like says 3 of 5 are OK, typically that means there's some pending checks that are running right now. You'll see that a number of them will have X's, red X's, which basically means that something within the automation has failed. Interestingly, this one shows 27 of 28 checks are OK. If this one here, you see 4 of 6. And again, 4 of 6. And basically what you can do is you can go and click on a PR. You can look at it. If you scroll down, and most people know this, but this is just here for the beginning of the education. If you scroll down, you'll usually see a box, and you'll see the test or tests that have failed. You can see the test name. In this case, it's the lint test. It's running against the Istio.io repo. The way we have these tests named is the repo name is at the end. It was against this commit. Here's a link to the basically to the job. In this case, it is a required test. And if you want to rerun the test, you can do test lint and put that basically in a comment, and that will rerun the test. Typically, that's if the test is flaky. If you click on the details and it's a flaky test and it might actually pass, feel free to do that. In the case of lint, more than likely, unless the linter is being changed under the covers, running the test again isn't going to change it. And then if you scroll down further, we also have this Tide merge bot. So basically, it's doing a bunch of things to make sure things are appropriate to merge. One of the common things it has at the top is basically, who is left to review it. In this case, you can see this PR needs to be reviewed by a workgroup doc maintainer infra person before it will get merged. You also can come down here and see a list of all of the checks. Not all of these are run by the Pro automation. The ones that end in istio.io or _istio.io are, and the other ones aren't necessarily. So again, you can see these are the tests that have passed. If you remember, it said 4 of 6 passed. And the key here is you can look at them, you can see which ones are required again. And you can also have the details, which is similar to the details link above. So in this particular case, I just click on that. It will take me to the job. If you wait a little bit, it will bring up a excerpt of the build log and show you, which might highlight the failures. In this particular case, nope, it didn't tell you what the failure was. If you look at the raw build stuff, you can typically read that and see what the problem is. In this particular case, there's a bunch of trailing white space on a number of lines, actually 8 lines. So the idea is if somebody were to look at this, go fix that, they can push another commit. Tide will basically rerun the jobs at that point, and hopefully the job will pass, and Tide would be okay with doing the merge once the approval was also done. Couple of things to point out in these jobs that I typically look at. You can look at the job history. In most cases, this works. Sometimes Prow has an issue with looking at job history. I don't know necessarily why. I believe there was an issue open for that. So if you look at the job history, you can see these 2 PRs have failed. Typically, if you look, you can see all the other ones are successes, so it's probably not a flaky test. And if you notice, you'll see some get aborted, and some people ask, why do they get aborted? Typically, that happens if somebody submits a new commit to the PR before the test has completed. So then what the MergeBot does, what Tide will do is it will abort the prior test and then start the test again with the latest commit. So in this particular case, you can see a commit came in at 7:28. You notice it usually runs about 6 minutes. At 7:30, another commit came in. So they aborted the first one. The second one was started, and that one was successful. So that's sort of a thing to look at in the job history. The test grid will show you something similar. Artifacts are important potentially if you're running tests, because a lot of times, like with Istio.io tests, the various test logs are within the artifacts. We can talk about that later if we want. Another key thing down here in the pod info is the test. If you look at the test, you can typically see what build tools image was being used. Usually there's some status, which is hard to read. In this case, you can see that the actual command that's being run in the background is a make lint. And we can see that later when we look at job definitions. And then the way things work is there's a bunch of, environment variables that are passed in, some that are talking with the job spec, some other things that are done, like, what was the pull request number? Is it pre-submit, post-submit? What was the repo and things like that. So if you think about these environment variables are being passed in and you're running a script or doing something like that in your command, you can look at what these values are, because you might do something, depending on the value. Example might be CI equals true is set. So maybe you have a script that says if CI equals true, now you're running in the automation as opposed to running locally more than likely, and so forth like that. And feel free to jump in anytime if you have questions or you want to go on a different path. But yeah, so that's sort of the key things. Looking at PRs, we look at Tide. Tide does some other things, like if you'll see some of these, I think if I go back and look, I know there's some in the list. You'll see that Tide will also look and see if a PR needs a rebase. If it does, it will basically say it needs a rebase and allow you to do that. So it checks for a rebase. It also checks to make sure that all of these tests that were run down here were run on the latest code. So if we have multiple PRs in, for example, so this PR was created, the tests ran, another PR gets created, and the tests are run, and that one merges. It will make sure that the tests are run in this PR as well before a merge. So you may see that it got approved and then it's rerunning tests, and that's basically because Tide is handling that for you. So that's sort of the idea of the pre-submit jobs. If we slide back out and I go and let's look at Istio, for example. So what you'll see is if you look at the top of the code view, you can see that there's some jobs that are pending. And if we go look at all the commits, you can actually see that these commits also have a symbol. Basically, it's saying, 14 of 32 jobs have run. Here, 23 of 32 ran or are run. One of them failed, and here all the jobs ran, and they were all successful. And why might that be important? Typically, you might go and look and see what didn't or what failed on a particular run. If you are familiar with what some of these post-submit jobs are, you might want to look. So one thing we do as part of the pipeline is we don't run all of the tests during pre-submit, i.e. before the PR is merged, against all of the Kubernetes versions. So if you look in the Istio.io, you see that we test against a bunch of Istio versions. We don't run all of those tests in pre-submit. We just use one Istio version, typically the latest. And then what we will do is we will run all of them against the various versions. So here's the integration test against 123. There should be other ones in here as well. Yeah, so 26, 27, 28, 25. So all these tests are being run against the other Kubernetes versions as well. An important one to look at, if I see it here, is release. So a lot of repos have a release task, and so here it is here. And basically what happens in the release is this is what generates the appropriate binaries that might be used elsewhere. So for example, this generates a copy or generates all of the images, the Istio images, as well as archive files given this commit. So we actually build a whole release for every commit, and you can get at it if you know where to look. It's not in the normal, if you will, Docker and GCRIO repos where our releases are, but it's in a testing repo. And I have a to-do to talk about that repo a little bit and how you can use it, say when you're running integration tests. So that's sort of some of the important stuff here. I want to go back and touch a little bit more on some post-submit tests and how it works in the automation. So here's API. We can look at that. We can see that they're all passing. One of the tests here that is sort of important is this update API dep client go API post submit. And why is that important? If we actually go and look at the job description, what this one does is it basically says whenever an API PR is merged, go and create a PR in the client go repo, updating the client go repo to point to this latest API commit. So what this job, post submit job does, so basically one PR merges, this post submit job runs, and you'll actually see another job get created in the client go repo saying, hey, update the API commit that's referenced here to the recently committed API. So we'll see that happen. And if we actually went and looked at client go and we see that that PR merges, it will kick off yet another automated job against Istio that has it point to the latest API and client go commits. So you'll see some automation that happens between repos. If you want to look at sort of what some of this automation looks like, I have another tab here, one that I typically leave open. Basically, if you look, it's looking at the polls, pull requests that are in the Istio org that are open. The author is Istio testing, and they have automator somewhere in the name. And typically these are these jobs like I mentioned earlier across repos. So this is basically the automation creating PRs for us. Typically they will start with automator. Most of them are auto merge, not all of them. There are some that we don't want to merge. We want some hands-on checking before they actually do merge. And some of them are actually on post submits. This particular one happens to be a periodic job. So daily a job runs and it looks at the ztunnel repository and checks to see if there is a new commit in the ztunnel repository since this was last run. And if there was, it basically updates the Istio repo to point to the latest ztunnel. In this particular case, normally all the tests would pass. This would go green. And because it's auto merge, Tide knows that this one can merge without anybody actually having to approve it. So these automator PRs, for the most part, don't need approvals. Like I said, if it doesn't have auto merge, it will. And this just happens to be a view that I look at usually, once a day or so when I want to come through and just to see where the pipeline is. And so if you actually go and look at this one, I know this one failed a couple days ago. I made a comment that it looks like there was only one PR that got merged into ztunnel between those two. And it seems to be causing some sort of test failure in the integ ambient tests. So usually we get some comments in there. And then sometimes, we'll make changes within this PR. Somebody will create another PR that fixes it and basically adds this to it. So that's that. So we talked about post-submit jobs. Looking at my notes, let's see here. Well, we talked about the release. We talked about them potentially causing multiple jobs downstream. Talked about auto merge. And I showed you this view. Another thing we can look at to see what's going on in the world of automation for Istio, go to prowistio.io. I just hit a refresh on this page. And this basically shows us all of the jobs that have been run are currently running or have been run recently. So you can see we've got some various jobs here. Here is a job in Istio. That's the PR that John put in. And you can see here are all of those jobs that are running. A bunch of them passed, a number of them failed. And this is just another view. You can click on this and it will, for example, like this lint, I can click on it and it takes us to the lint job. And there we can, if it was a failure, we can look at it and see what failed. So that is sort of how that view works. Sometimes you might want to just say, look at Istio.io. I'm curious what's going on in Istio.io. I can select that and I can see what's going on. Oh, one other thing I guess I can sort of talk about because it sometimes happens. And I will bring up this. Let's see if this will show up now. So here is Istio Slack, and we have a test failures channel out there. And it shows basically whenever one of these automated post-submit jobs fails. We don't really care in test failures about pre-submit jobs. Somebody else is looking at those. A lot of people don't look purposely at the commits and the red check to see what might have failed. So this basically is a channel that allows us to look at the jobs that are failing in post-submit. Typically something that might end up being in here that, let's see if I can find something. But yeah, typically you're looking for something where you just basically see the same job always failing, which may mean that something got checked in that's causing the post submit to fail. An example might be we checked in something that doesn't work on Kubernetes 124. We would never see that in pre-submit, but then we might see the Kubernetes 124 job failing on every Istio merge after that. And so then we have to go and sort of look and see and say, hey, why is that failing and what did it fail? But we're not going to see it here. I don't have a good example of one, but a lot of times you can go into job history and you will see that basically all of the current jobs, so maybe the last 8 or 10 runs, the jobs are red. And then we basically have a bunch of green jobs before that. Well, more than likely something in the job, the first red job is the PR that probably put something in that broke it. So you might want to research that as well. So some more stuff that, if you're into TNR or just wanting to learn how some of this stuff all works together, that's how that works. So any comments from anybody or questions about these jobs? I'm going to sort of go into test infra next and sort of show you how they're created, but anything in terms of, how they're run, Prowl running them, looking at test output. Otherwise, I'll just keep on going. All right. So test infra. The Istio infra repo, it's basically the repo that's in charge of setting up most of this automation. If you go look at its basic README, there's a bunch of stuff here that with links. Maybe you're interested in Prowl. What we're going to talk about here shortly is, creating new jobs. That might be updating current jobs. If you want to learn about what our cloud infrastructure looks like, here's a link for that. And then there's a number of tools that we use as well. You notice I mentioned Automator. Automator is a pretty common one. It helps us handle the automation of dependencies between things. So that's why you see these Automator PRs. I pointed out the build tools image that was used. So basically if we go and look in the Istio tools repo, there's a Docker file that is out there for creating the build tools images. So in there, we update things like the Go version of other various tools that we want to use. Hugo for Istio.io, for example, within the tools build image. so that we, and the reason we have the tool or the build tools image is so that we know that we're using it in Prow, and you can also use it locally on your local machine. So you're able to do all your development and testing basically. I shouldn't say all, the majority of your testing and running and stuff within a Docker container, either on your local machine or somewhere locally. You don't need to, necessarily spin up a PR to go and have the tests run. You can run them locally. So like, for example, you want to do a make gen. A make gen is a common thing. There's a gen check test that will sometimes fail. You can run that make gen locally, and it uses the same build tools image that's used by the pipeline. So everything should be the same, and you don't need to install all of these tools that are used within the build tools. We just use the build tools container. So let's look at sort of the Prow config jobs. Actually, I think if I go to this README. So basically this is a README, it's in Prow config jobs. It talks about how to add a job, sort of the schema that's out there, right? All jobs have a name. Basically that's the name that you see as part of the test. The jobs have some sort of command or entry point that's defined. They could be periodic, a pre-submit job, a post-submit job. By default, they run in both pre and post, but sometimes you only want them to run in a particular one. Like I said, the various Kubernetes versions integration tests are only run in post-submit. So you can say, you can do some things like running those only, what do I want to say? They will only run in post-submit. You can do some things like you can say pre-submit skipped. So that just means that it's not going to be run as part of pre-submit, but you can actually go do /test space name, and it would run the test for you. So maybe you're creating a test and you want to not have it run all the time or run at all unless you're running it. So that might be where it might work. You remember I had is the test required to be merged, pre-submit optional? That basically turns the required off. And hidden basically means that it's going to be not show up in the GitHub UI. Tests or jobs can also require other things besides just the job. Maybe they need to have kind set up. They need a kind cluster. Maybe you're running some Docker commands, so you want them to be able to be set up to run Docker. There's some other resources, architectures, and things like that. But we can look at some of those. So basically the idea is, if we go into Prow config jobs, and that's what this view is. So here I'm looking at the Istio.io YAML. And so Istio.io YAML, these are the jobs that are defined for the master branch of Istio.io. If we actually scroll over here, you can see there's Istio.ios for the other branches, 19, 20, and 21. And so basically, if you check something into release 121 branch of Istio.io, here's the stuff that's going to run. Here's the stuff that's going to run on 1.20. Here's the stuff that's going to run on 1.19. I will tell you that the ones that are on the named branches, not master, the YAMLs look much, I want to say much less nice. These are pretty straightforward. Just as an example here, let's look at the 1.21. Because all the fields end up getting filled up, it's not as nice to read. If I just go look at the main one, the only thing that's there are, basically the non-defaults. So let's talk a little bit about this file as a whole. So again, this is against the Istio.io repo. Basically, the support release branching statement being true means that if we're going to do a release branch, I want to create, so I'm going to do the release branching for 1.22, for example. I want to create the Istio.io-1.22 file. Some repos only have a master branch. So then this would be false. We don't need to create a new YAML for the release just because we only have master. Common files would be not one of those. Let's see. Community would be one. Community does not only has a master branch. So you see it does not have all of the other YAMLs. And then within the Istio.io YAML, for example, you can see here are the jobs. So if you remember, there was one called Istio or lint_istio.io. This is that job. It's a fairly simple job, as it showed in the job description when we're looking. All it's doing is a make lint. There's also a gen check job that does make gen tech. There's also some other jobs. So here is, for example, a job that runs a doc test profile default. It's basically running this command with this parameter. We talked about requirements. So this one does require kind and some resources. And in this particular case, there's also a regex that says when this test needs to be run. So in particular, this test only needs to be run if something is updated in go.mod, in the test directory, in the package test directory, maybe in test.sh or snips.sh. If we see something like that, one of those changes within the commit, then this test is going to run. So a lot of times you'll see there's our regexes that prevent tests from being run in a lot of cases. Common files has some of those. Again, they can be formatted somewhat different. In this case, you can see its entry point. Each value is separated by a comma. And here we can see they're just separated out in a longer format. Again, requirement of kind. So basically, the idea here is if you want to, I'll point out periodic as well. So here again, here's a job that's only run during pre-submit. And again, it's optional. So if this test fails during pre-submit, it won't prevent the test from being merged. And another interesting thing that you can sometimes see in here is this is repos. So by default, when a test runs, it will pull in the current repo associated with the name. So this will automatically pull in the istio.io repo. But in this case, it's also saying, hey, we want to pull in the test infra repo as well. And typically the reason that you want to do that is because your command is going to be then something like /test infra. So now we're actually running some code that's in the test infra repo as opposed to locally. There's also periodic jobs I mentioned. So here's a periodic job. It runs every Sunday at 2. And again, here's the title. It's Automator. And it's running Automator from test infra, and it's doing a particular script. In this case, it's actually not a script. It's just doing make update test reference. It could very well be a script. And then here's sort of all the resource presets. So like I said, during release branching, it sort of flushes everything out, and that's what creates these files. So that those are a little bit more complex, at least in trying to read them. One thing you do need to do is if you decide to create a test and you go and actually, I think I go over here. Oh no, that did get merged. Let's just go over here. There was one I saw yesterday against test infra. Get merged. So, well, okay. What I thought? Okay, maybe it's still here. Oh, yeah. Here's some various ones. So here's one that's some jobs for, it happens to be the stale operator repo in Istio ecosystem, but there are some jobs. So in this particular case, they created a brand new repo. These are the jobs for the repo as opposed to adding a single job. But again, you'll see that here's a list of the jobs that get run as part of that repo and things getting done. The reason I wanted to point this out is you will also see that there's a whole bunch of generated YAMLs. So if we go back over here and look at the config jobs, there's actually a bunch of things in cluster jobs, Istio, and you'll see istio.io, and you'll see this Istio.io master gen YAML. And so this is a generated file, which is the actual config that Prow's using. So you make the other Prow config jobs and you do a make gen, which will either update or create these files as appropriate. So if you add a job in if you add a job down in the IO file and you run make gen, it will update and add the job into the master gen YAML file. So hopefully that makes sense. So from a real, high level down to, at least a somewhat moderately deep level on, the automation, the jobs, creating jobs. That's sort of what I have. Any questions at this point? All right. I think I want to leave the doc contribution stuff out for right now. We'll see where we get here. I think I want to slide forward a little bit to talk about tests and how they're done. So we have a couple of different sorts of tests that you can write. The first one, and the one I am more familiar with because I do this one quite a bit, if not debugging them, creating them. And that's the Istio.io automation testing that we have. So basically, the reason I sort of showed the Istio.io stuff before is if somebody updates a go.mod or updates a particular test, basically that means we want to run our Istio.io tests against those PRs. And we have those set up for the various different environments. So if we, think about if you have the, you're using the demo profile, we actually look in setup, you can see if we have, the demo profile, we have some for the default profile, the minimal profile, or sometimes it's profile none. And that's basically jobs where you want to do the Istio install yourself. So the test script will have all of the Istio install stuff. We also have multi-cluster and dual stack. But the idea here is, how do we make a test? There's a couple of things you can do. If you look at the index.md files for a particular document, there's a field in there that says test, and it may say no, it may say yes. And that basically tells us whether we want to have a test or not. If you set the test to yes, what will happen is when this make snips command is run, it will generate a snips.sh in the same directory that the index.md is in. And it basically will have all of the bash commands that are in the index.md created within code blocks. I can probably show you what one looks like here shortly. And there's a couple of things you can do. By default, they're going to have, like, say, snip, the section title, and then a number. So in this particular case here, it's, there's apply weight-based routing section. So the snip is going to be called snip, apply weight-based routing, and the first one in that section will be number 1, the second will be number 2, so forth. Typically, if you're doing this the first time, so you've done the turn it to yes and say make snip, you might want to do a make lint fast. And the reason is the linter checks all of the snips to make sure that they're valid shellcode. So sometimes this will turn up an error in the shellcode where you then want to go and maybe update the snippet that's in the index.md file to pass the linter, run make snips again so that it updates the snips.sh, and then that will make the lint pass. Sometimes you might want to set snip ID equal to none, and then what will happen there is it will not generate the snippet for that. So maybe there's some snippets that you don't need created, and or ones that you don't need as part of the test that you're going to not need in the snips. So then you're going to go and create a bash script named something test. Might be part 1 test, part 2 test. But basically we look for anything that ends in test.sh. And inside there, you will basically do some execution of some commands. So you might execute some of the commands that you saw above. And we have a bunch of utilities things. So you might do like wait for deployment. So you say deploy default deploy HTTP bin, and then you say wait for deployment. So you're going to wait until that's deployed before you go on to the next step, and so forth. There's some other things that I will touch base on quickly. If you look at the top of the file, you'll see the setup. So this one's profile none. So this test will only be run if profile none is specified. So if you're like running the profile default, for example, this test is ignored. There's a section called cleanup in the script, and that's basically the cleanup that happens. So what happens in the script is we actually go and basically try to snapshot everything that's available within the Kubernetes environment. We run the test, we then run cleanup, and then when that's done, we basically go back and look at what's in the environment again, and we want to make sure that nothing is left behind or nothing extra was deleted. So let's just quick. I haven't really picked on which one I want to do, but let's just look at one. Getting started. So getting started has an index.md. If we look at the raw text, you can see the test is yes. So then we run it, we have a snips.sh that gets created. So this is the auto-generated file. You can see that here is a bunch of the stuff that gets in there. So these are basically, if you went and looked in the index.md, you would see that there's this snippet, this snippet, this snippet, and so on and so forth. And maybe with a particular snippet, we said Istio install in the index.md. Oh, and by the way, here's what the output would look like. That's what's in the index.md. And then what we do is we just create this test file, and this is created by the person creating the test. A lot of times we'll just yank the same top stuff. In this particular case, we know we want to use samples, so we want to use the samples.sh. And then we basically just add a bunch of things. So here we're doing, snip install Istio _1. We're waiting for it to deploy. Then we're going to add the label for the namespace. And then basically we do a install Istio #2. If we actually went and looked and see what that does. So here's one, does an Istio install. #2, interesting. So install 2 should do the same thing as the other one. So I'm inclined to say maybe we have an issue with that test. Oh, okay. So this is not, what this is doing is this is removing the label so that when the snip install test 2 runs, the label will be added as opposed to the label already exists message popping up. So that's what that's about, not that it was adding the label. And then you'll see some cleanup. So we might do some cleanup, and then we might do deploy. And then you'll see things like verify like. So in this case, we're going to run this command and verify that the output is like this. You might do verify the output contains something, right? So the output that's on the index might be something that's a part of the total output. So verify contains, you might do some other things. Again, here was the cleanup section. So it's going to do a cleanup book info, snip uninstall, and then delete the namespace. So that's sort of the doc test. I want to also, and this is a thing that we probably might want to cover a little bit more in depth later. And again, it is somewhat slightly different depending on what you have locally. And this is, okay, if I want to run the integration test in Istio, in the Istio repo, for example, what do you need to do? I had a different setup when I used to do this when I had Docker Desktop installed on my Mac. We can't run that anymore within IBM, so I have a different environment set up. So I'm basically running a Linux VM, and inside the Linux VM, I have Docker installed, and basically I do all my development inside of the VM. So using remote VS Code and things like that. So a benefit here is the command line inside of my VM now has all my Linux commands. It's not Mac commands, so that's good. But it also results in some things being slightly different. So just a real quick running an integration test. What do I do to do that? So there's a couple of things that I set. So I do an export. There's actually a couple of exports I set. Let's just go to this. The first thing I do is I update the hub. In my case, I don't want to use a local build. Maybe in my case, when you want to run it, you're running something you just built because you're testing something locally. So the hub might be your name, might be Eric VN. That's my default. But in this case, I want to set it to Istio testing, and that's because I'm going to use basically a version of the Istio that was created by the release job. So I know that all of those images are in the Istio testing. In this particular case, I want to set the tag to be something that's currently in the master branch. So I know that the master branch tags right now are 1.22-alpha.the commit. So I happened to do a git log, looked at the commit, and this was the latest commit. The release job had finished, so I know the images are out there. So I just export this tag. And then the other thing I typically do is I set the test flag to be running whatever tests I want to do. In this case, I wanted to run test traffic. So basically, I set those up, and then basically I run this command. I run this integration suite kind. And the way I run it now is I run this in my VM instead of inside the build tools. In the past, I used to have to run inside the build tools. And basically, I want to run all of the integration tests that are on Cube specifically for pilot. So if we actually go look in this make file, we will see that we're going to run tests against this pilot, the integration test pilot directory. So we'll run all the tests, and we'll only run the tests that are related to Cube. And that's partially because I'm running the kind test, right? So what this will do is it will spin up a kind cluster for me, install metal LB into it, and then run all of the tests. And this is actually a run right above it. It ended up failing. I have not had a chance to go back and look through what the failure was. But if I go back up and go through all the output, you can see here's the test traffic tests. For the most part, they passed. So that's one way to run it. Some of them are skipped, for example. And I don't really have time to go into how to write integration tests, but we can potentially do that in a separate item if people think that that's important to do. So we're to the top of the hour. I know we started a little late, so it's not quite a full hour worth of stuff, but I know people probably have to go to other meetings. Any questions? Anything people want to quick talk about? It doesn't sound. All right. You're welcome, Whitney. So I guess from a bookkeeping standpoint, if we can get the recording to Francis at some point, then I think Francis can